Good morning and welcome back to the sixth section of Chapter 3. In this one, we're going to look at solving linear systems in three variables. This is the last section in Chapter 3, and it's one of my favorite topics of the entire year. And I'll tell you a little bit why that is a little bit later on. So, our learning targets for today. I can represent solutions to systems of equations in three dimensions graphically, and I can solve systems of equations in three dimensions algebraically. And remember, a linear equation in three dimensions does not graph a line, it graphs a plane. And so, one, we can be thankful that we're solving these algebraically because trying to solve them graphically would be amazingly difficult. But second, what could planes do in three dimensions? So when graphing three systems in three dimensions, we could have a few different things happen. All the planes could intersect. Think about the corner of a room. You have two walls and a floor, all intersecting at a single point. And that gives us one solution. Those are independent systems. We have other options, though. We could have all three planes intersecting in a line. Think about the pages of a book being planes. They're all intersecting at the spine. And so they intersect together in a line instead of a point because they're all going in the same direction. And we could have a few different ways where there are no solutions. The first and most obvious would be if we have three parallel planes. Think about like three walls in the same house all facing the same direction. We have three parallel planes. But that's not the only thing that could happen. We could have two parallel planes and then one that intersects. It's called a transverse plane. For instance, two parallel walls and the roof or the floor. They'll intersect, but not all at the same time. And then we could also have them come together to form a triangle where each of the planes intersects with the other, but they don't do it at the same time. So these two intersect at this line, these two intersect at this line, these two intersect at this line, and there's no one place that works for all three planes. So when we're graphing three systems, these are the types of things that can happen. Now, the one solution, this is going to be the typical. And they won't be perpendicular to each other like that necessarily, but we will get one solution. And so how do we find those solutions? We're going to solve them algebraically. Now, I have a few tips for success here, because as you see, this is going to be these are going to be big problems. And my very first tip for success is to be organized. If you are not organized in doing this work, you will be at a disadvantage. Also, develop a system. When I do these problems, every single one of them will look the same. Everything is in the same spot, and that way when I'm checking, I know exactly where to look for different things. Show your work. More importantly than ever here, there's pretty much no way you're going to be getting these without showing your work, at least not accurately. And show even the little steps, because there's lots and lots and lots of mistakes to be made, and one little mistake will mess up the whole problem. And finally, don't make those small math errors. I know that's easier said than done, but work to be precise in your mathematics. It will save you frustration down the road. So, how are we going to do these? We'll start out with a system of equations. Here we have x plus 2y plus z equals 8, 2x plus y minus z equals 4, x plus y plus 3z equals 7. And my very first step, and that goes to my organized part, is I'm going to number these. I number them 1, 2, and 3. And I make a little circle around my numbers so I don't think that I'm multiplying by those numbers. I know the teacher next door is like, why don't you just use A, B, and C? And I thought, well, that's brilliant. Why don't I do that? And I tried. It doesn't work for me. I need the numbers. So label your equations, because now we're going to use elimination to get rid of one variable. We're going to have to use elimination twice, and we're going to get rid of the same variable. It doesn't really matter which one we get rid of. Sometimes one variable is going to be easier than the others. In this case, all of these are going to be pretty easy. I'm going to choose to get rid of z, simply because this one is already negative, so I don't have to change the sign. So I'm going to use equation 2 twice. I'm going to add equation 2 and equation 1, and equation 2 and equation 3. So with equation 2 and equation 1, when I add them, these z's are already ready to go. So I can just have equation 1 plus equation 2. And then for equation 2 and 3, I'm going to have to multiply equation 2 by 3. So they'll have a negative 3z and a positive 3z. So we have 3 times equation 2, and then just equation 3. I call this my game plan. It lets me know, all right, what am I going to do? And so now I can actually put the equations into it. By doing this, I don't forget what variable I'm getting rid of, because that's what I'm thinking of right now. And I don't accidentally start multiplying by weird and crazy things. I know that I'm just going to have equation 1 and equation 2, and then I'm going to have 3 times equation 2, and I'm going to have equation 3. So there's equation 1, just written down exactly. Equation 2, written down exactly. 3 times equation 2, that was 3 times 2x is 6x. 3 times y is 3y. 3 times negative z is negative 3z. 3 times 4 is 12. Notice we had to multiply everything. And then equation 3 is just equation 3. Now we can add these together, and when we do, the z's here will go away. That's by design. We'll get 3x plus 3y equals 12. And over here, z's go away. We'll get 7x plus 4y equals 19. That gives us 2 more equations, equation 4 and equation 5. And now these 2 equations only have 2 variables. Notice we got rid of the same variable. That's one of the mistakes people make. They'll get rid of z's here and y's here. That's not going to help you. We got rid of the same variable. Now we have x's and y's, x's and y's. We've played this game before. We can do this. We could use substitution or elimination. It's already set up for elimination. That's what I would stick with. In this case, you could use substitution over here. You could get either x or y by itself. It would work. But in general, I would stick with elimination. And so we have equations 4 and 5. Which variable are we going to get rid of? Well, we could turn both the x's into 21s, or we could turn both the y's into 12s. Let's go with the y's. So we have, we'll have to multiply by 4 to equation 4, and negative 3 to equation 5. And so 4 times equation 4, we're going to have 12x plus 12y equals 48. And negative 3 to equation 5, that'll be negative 21x minus 12y equals negative 57. Add those together. 12 plus negative 21 is negative 9x. The y's go away. 48 plus negative 57 is negative 9. So negative 9x equals negative 9. Divide by negative 9, x equals 1. Is that the answer? No, it is not. We need to now plug this in to either equation 4 or 5. I wouldn't use these guys because they're just bigger. Let's plug it into equation 4. That one looks a lot nicer. So when we do that, we'll have 3 times 1 plus 3y equals 12. 3 times 1 is just 3, so we can subtract. So 3y equals 9. Divide by 3. y equals 3. And then we need to take both of these two and plug it into one of our original 3. Let's choose the first one. So we'll have x, which is 1 plus 2 times 3 plus z equals 8. 1 is 1. 2 times 3 is 6, so this will be 7 plus z equals 8. Subtract 7, so z equals 1. And so our answer, x, y, z, 1, 3, 1. Now if you had a word problem where it wasn't necessarily x, y, and z, but there's some like how many medals do they get? First, second place, third place. I just list out like 7 first place medals, 5 second place, and 1 third place, or something like that. But when you just have x, y, and z, ordered pair is good. Now, so I mentioned that this is one of my favorite topics of the entire year. And I do love this, both as a teacher and from when I was a student. As a teacher, I love this because, 1, it forces you to show your work. 2, it forces you to not make little mistakes. You will make little mistakes in the beginning, but you will go back and you will figure out what you did wrong to get the right answer, and you're going to stop making those mistakes. And it's wonderful. I see it every year, and I love that part as a teacher. I also love that it's really easy to go back and evaluate your work, figure out where you made those mistakes. And so that's a great process that you will be getting into. Why did I love this as a student? 1, because these problems are long enough and hard enough that when you get to the end and you get it right, especially on the first time, you actually feel good. You feel that sense of accomplishment. And you're probably laughing at me right now. That's okay. You will get it. And the other reason why I love this as a student is because these problems are long. They take up a bunch of time. They take up, well, not a bunch of time, but they take a bunch of work. And no individual step is very difficult. But when you sit back and look at it, it looks hard. So when people come up behind you and say, like, oh, what are you working on? Oh, wow, that's hard. You must be really smart. Just own it. Yeah, I am. So, lots of reasons to love these kinds of problems. Let's try one. So, I did one for you. Do you see the steps? Let's try one. Try this system. 2x minus y minus 3z equals 1. And 4x plus 3y plus 2z equals negative 4. And negative 3x plus 2y plus 5z equals negative 3. Pause the video. Actually do this. Pause it. Try solving the system. Follow the steps. See if you can do it. When you think you have it, push play, and I'll give you the answer. And then we'll go from there. All right, did you actually do it? Or did you just wait for the pause to go away and you're waiting for other people to learn for you? Actually do the problem. Participate in your own education and do the problem. All right, so at this point you've either actually done it or you don't actually want to learn. So the answer is 2, negative 6, 3. Is that what you got? If yes, congratulations. If no, go back, see if you can find a mistake. When you're looking for mistakes, look at the first one that you did. The very first one that we did over here, I figured out what x equaled. Is my x right? If yes, then this part is right. Go to the next one. If this one's right, then this part's right, and your mistake's over here. If the first one was right, but the second one was wrong, your mistake's in here somewhere. And so you can use that to help find your mistakes, and that can be huge. If your first one was wrong, which is generally the case, it means your mistake's up here somewhere, and it takes a little bit more work, but you know where you're looking. And the very first thing I would check is, did you copy down the problem correctly? All right, so go back to find your mistake, and then we'll move on to the next slide. So pause and find your mistake, and then come back. Are you ready to come back? All right, let's look to see how I did this one. So if you did it the first try, you're probably pretty much done at this point. If you're still struggling, let's look through this problem. So we have 2x minus y minus 3 is equals 1, and 4x plus 3y plus 2 is equals negative 4, and negative 3x plus 2y plus 5 is equals negative 3. I'm going to number them first, because that's what I do. All right, let's see, which variable should we get rid of here? The x's, well, ideally not, because the 2 and 4 would work. 2 and negative 3, that one's a little bit tougher. The y's, I could change this y into both of these pretty easily. And the 3's, or the z's, that's right out. Let's not do that. The y's look like the easiest one to get rid of first here. So we'll need equation 1 we'll use twice. We'll go 1 and 2, and then 1 and 3. For 1 and 2, we're going to have to multiply 1 by 3. And then for 1 and 3, we're going to have to multiply 1 by 2. We have 2 times 1 plus 3. So 1 times 3 will be 6x minus 3y minus 9z equals 3. And then just equation 2. And then equation 1 times 2, 4x minus 2y minus 6z equals 2. And then just equation 3. Now we can add these together, get 10x. The y's go away by design. And minus 7z equals negative 1. And over here, that's 1x. Y's go away. Minus z equals negative 1. And now, those are equations 4 and 5. So now we need to multiply. Let's get rid of the z's. So let's multiply this one by negative 7. So we'll have 4 times negative 7 times 5. So equation 4 is just 10x minus 7z equals negative 1. Negative 7 times 5, that'll be negative 7x plus 7z equals 7. We can add these together. 10x minus 7x is 3x. And then the z's go away. Negative 1 plus 7 is 6. Divide by 3. X equals 2. Plug this into one of them. Let's plug it into equation 5. So we have 2 minus z equals negative 1. We can subtract the 2 over to get negative z equals negative 3, which means z equals 3. And then plug both of these back up into one of the top ones. Let's go equation 1. We'll get 2 times 2 minus y minus 3 times 3 equals 1. 2 times 2 is 4. 3 times 3 is 9, not 6. That's one of the mistakes people make right here. 4 minus 9 is negative 5. And so we can add the 5 to get negative y equals 6. So y equals negative 6. So our solution is 2, negative 6, 3. Did you see where you made a mistake? Did you go about it the right way? Or the same way? So this is what we're working on. We'll be doing a lot of practice on these. And yes, they do take longer, so no, you won't have quite so many problems because they do take longer. But I will see you later. And until then, happy mathing.